Peace, a prize fought for by all, but found by few. A prize that brings life even to the darkest of moments. Where do you find your peace? Do you find it in the tranquilities of the ocean? Or in the vastness of space, with stars that speckle the earth? Maybe you find it in the beauty of an island untouched by human hands, or the simplicity of the falling of a raindrop. Peace.
Namaste. My life used to be defined by stress and anxiety, but then I discovered my place of peace: horizontal and vertical lines. I used to think that was a very difficult thing and I was overthinking it greatly. But then I realized, no, this is peaceful. This is relaxing. Let's just let this be very easy. If you find yourself overthinking horizontal and vertical lines, you're living a life of stress and anxiety. Be like me. Relax. Take it easy. Thank you.
Oh, hello. Shalom. Namaste. I was just meditating upon easy, simple, mathematical, algebraic topics. And one of the things I was thinking about was vertical and horizontal lines. I find them to be easy and simple and not something that we need to panic about, but something instead that puts us in a nice, relaxed state. You too can be in a nice, relaxed state if you learn how to do vertical, and horizontal lines. Once again, vertical and horizontal lines. Let's talk about it. View your notes, of which you should have. First thing we need to remember is what vertical means. It means up and down. A vertical line is written in the form x equals a, where a represents the lines x-intercept. All you got to know are the axes of your coordinate plane. Remember, the x-axis is always the one that goes side to side. So whenever we're dealing with this, that is the thing that we're going to be crossing. A vertical line will always cross that x-axis. That's what it does. It creates an x-intercept, which means crossing the x-axis. The equation of the line graphed above is, well, it's very simple. You just put the x value that it's crossing. To write the equation of vertical and horizontal lines, we're just writing down the thing that's getting crossed. We are crossing the x-axis at 3. 1, 2, 3. So the equation of the line is just x equals 3. That means that no matter where we are on the graph, we're always going to be going to the to the right. Wow, get it right. We're always going to be going to the right by 3. See? Everything here is always over by 3, over 3, over 3, over 3, over 3. No matter what the y value is, we're always going to the right by 3. Now we know that the slope of this thing is undefined. Vertical lines, undefined slopes, not even a function. So this is one that's really icky. Whenever we see something like that, it's icky. But it's also easy, because you just have to write down, hey, what's happening here? We're just moving to the right by 3 every time. That's the thing that we're crossing. The one that you might see a little bit more often is a horizontal line. Horizontal lines always cross the y-axis. Remember, the y-axis is the thing going up and down. So when we go horizontal, that's the thing that we're going to be crossing. So whenever we write our equation of this line, it will always be in the form of y equals a number, because we're crossing that y-axis. It has a y-intercept. Notice it doesn't cross the x-axis at all. It's just not going to do that. It's only going to cross at y equals -1, because it went down by 1. That means no matter where I am on this line, I'm always going to be going down by 1, forever and always. So to write the equation of horizontal and vertical lines, simply ask yourself, what is it crossing and where? If it's crossing the x-axis, that means it's got to be a vertical line. And wherever it crosses that x-axis, you would just put x equals that number. That's how you would write the equation, that line. But if it's a horizontal line, it will always be crossing that y-axis. So you're crossing at y equals whatever that number is. In this case, it was -1, because everywhere on the line is going down by 1. That's pretty much it. It's easy if you know how to do it. And now you do. So let's look down further on our notes. The bottom section here is asking us to write the equation of the lines that are shown. It's a little bit hard to see exactly what's going on here. I know the lines kind of get all befuzzled, but the ones with the big arrows, that's the line that we're actually talking about. The one with the small arrow, that's just your axis. So this is a vertical line, and it's crossing the which axis? You're right, the x-axis. See the x-axis here? And my line is crossing it right there. Since I'm crossing the x-axis, that means I'm going to be dealing with x equals, in this case, it's crossing at -2. That's it. Number 2, we're crossing the which axis? The y-axis, you say. You are indeed correct. We're crossing that y-axis right there. Since we're crossing the y-axis, that's a y-intercept, that means our line has to be horizontal, as you can see. And so we're going to write that we're at y equals 1, 2, 3. +3. As we're going up 3 from the origin. The last one, it's all the way down here. You'll notice that it is also crossing the y-axis. So that means it's a y-intercept. So y equals 1, 2, 3, 4, 5. -5. Go ahead and pause the video and try the bottom 3 on your own. Numbers 4, 5, and 6. Probably already done it while I've been jibber-jabbering. But if not, go ahead and pause, complete these, then hit play, and see if you got them right. Ready, set, go. Ta-da! You have got to be kidding me. One moment, please. Ta-da! All right, so hopefully you got something that looks like this. The number 4 is crossing the x-axis at 4, so it's in x equals 4. This one's weird because it's just running right on that y-axis, right? It's going right down the middle, but it's crossing the x-axis at 0. So we would call that x equals 0. That's a really rare thing to see. And then this one is a horizontal line that's crossing my y-axis at 2, right? We're going up 2 to get there. So that'd be a y equals 2. So something to memorize would be that if it's y equals a number, that means it's a horizontal line. If it's x equals a number, that means it's a vertical line. A further way to remember that would be that y equals is the thing that we typically use for lines, right? Y equals mx plus b or y equals whatever. So that's a bit more of a normal thing to see. In the same way, when we see a horizontal line, we don't panic. Like, that's an okay thing. It's a function. It's just a really boring function. Whereas we don't do like x equals whenever we're talking about the slope of a line or anything like that. So if you see x equals a number, that's really rare and weird. In the same way, it's dealing with a vertical line, which is not even a function. It fails a vertical line test. Like, it's just, its slope is undefined. Like, it's just like an icky thing, so that's why we don't see it much. So that's just something that you can kind of commit to your thinking memory. But even if you can't remember anything, let's say that you have something wrong with your brain where you have short-term memory loss and long-term memory loss and you just can't remember anything, that would be sad. Also, you don't have to, because at the end of the day, you can just look at your line and ask yourself, what is it crossing? If it's crossing the x-axis, it's x equals whatever that number is. And if it's crossing the y-axis, it's just y equals whatever that number is. So even if you can't remember it, it's still easy if you know how to do it. If you flip that over to the back, it's just asking you to do the complete opposite. Instead of giving you the graph and you write the equation, it's giving you the equation and then you have to make the graph. So you have to know, am I doing a vertical line? Am I doing a horizontal line? Like, what's going on here? And the key is just remembering that we're just drawing a line that's crossing whatever it tells us to cross. So number 7 says y equals 5. So that means I'm crossing the y-axis at 5. So here's my origin. That's like the middle part. So I'm going to go, y-axis is up and down. That means I'm going up by 5 to get to y equals 5. 1, 2, 3, 4, 5. There's your dot. And if I'm going to cross that, that will automatically make it a horizontal line. Some of you will have that memorized. You'll see y equals a number and you'll be like, oh, y equals means it's a horizontal line. Others of you may not have it memorized, but you'll figure it out once you get there. Because you'll at least remember to go to y equals 5 on your y-axis. And then when you cross it, it'll automatically make a horizontal line. 8 says x equals -1. Again, some of you may memorize that x equals a number means vertical line because it's bad and icky. Others of you may not, but what you could remember, everyone can remember that we're dealing with the x-axis, the side-to-side axis. So if we go back 1, and I need to cross that axis, the only way to do so is to make this vertical line that goes up and down. So even if you don't have it memorized, you could still get it right. Go ahead and finish the rest of those, and then pause the video. Pause the video, do the rest of those, and then hit play. Do that. All right, so hopefully it looks something like this. Your x equals 3 is vertical. Your y equals -2 is horizontal. Your y equals 4 is horizontal at +4. And your x equals -7 is vertical at -7. Easy? Maybe, maybe not. The last couple on there are really just like reminder types of questions. And so I'm just going to talk about these really quick. Make sure you kind of tag these onto your notes as well. I just want you to make sure you have them in case you ever need them in the future. Like any time in the future, like even 20 years from now where you still got your notes from Algebra 1 class. That would be so cool. But anyways, it says, what is the slope of the line y equals 4? Well, y equals 4 means I'm crossing the y-axis at 4. So that's a horizontal line. The slope here is just 0. Agreed? Good. You should probably agree. I'm a math teacher after all. The slope of the line x equals -2, well, that's going to be the vertical line. Vertical lines have a slope that is undefined because they're bad. Yes, they are. What is the slope of the line x equals 0? Does it change since it's a 0 instead of a -2, like the one above it? Well, no. No, it doesn't. Still a vertical line, and it's bad. So, undefined. Haha. Now, this is a weird one, and this is a word that we're going to be using, like, literally in our next lesson. So, probably want to get to know what this word means. It says, which axis is y equals -1 parallel to? Parallel means you run right beside it. You're like the same as it, just in a different spot. And so, if we are dealing with y equals -1, that means we're dealing with like a horizontal line, side to side. It's asking which axis, x or y, are we parallel to? What are we running the same as? Which axis goes side to side, just like my horizontal graph does? Yeah, that would be the x-axis. So that's kind of a unique type of question that's just testing a lot of different things that you understand. As long as you know that y equals -1 is going to create that horizontal line, you can know that that's parallel to the x-axis. It never actually crosses it. Similar on this next one, which axis is what x equals 4 parallel to? Well, x equals 4 is a vertical line. So it crosses the x-axis, right? X equals. But it's parallel to the y-axis. That's the one that it's running right next to. And we'll talk more about parallel in the next lesson. How does the graph of y equals 3 differ from the graph y equals 3x? Graph both and explain. So this is kind of a neat way, and this is, I mean, we talked a lot about this type of stuff when we did slope-intercept form. So this is like right when we started graphing. We talked about how we're dealing with y equals mx plus b, and we talked about how if one of these pieces, either the mx or the b, if one of those pieces is not there, it doesn't mean that it like doesn't exist as much as it means that it's just 0, right? Because we don't need to write plus 0. That's redundant. We don't need that. So there's going to be things missing in these, and we can still graph the lines. They're just going to make different types of lines. Y equals 3. The y-intercept here is 3. That would be technically my starting point. I'm going to make this blue just to stay consistent. But notice we're missing the mx part. So the slope in this case is 0. But we already knew that if we wanted to graph that, that's just a horizontal line. And that's why it's a horizontal line, by the way, because the slope, the mx, is 0. It's not there. We don't need to put it because it's 0. So that's why a slope of 0 just stays unchanging. However, y equals 3x, we tack that x on there. That x is important because that tells me that we're talking about something completely different. Now, y equals 3x has this mx part. What it doesn't have is a constant, the letter without the x. That constant is supposed to be the y-intercept. That's supposed to tell me where to start. And if it's not there, that means well, let me rephrase. That doesn't necessarily mean that it doesn't cross anywhere. It just means that it crosses at 0. So that means I'm going to start at 0. And then my slope from there is up 3 over 1. Up 3 over 1. So you're going to have something that looks like this. It's not vertical, but it has a pretty steep slope. So all this is wanting to remind us of is that if we have a y equals a number, this is kind of what we've been working with, we're going to end up with that horizontal line. It has the y-intercept of 3, but its slope is 0. There's no x part to it. That's why it's flat. The other one has a y-intercept of 0, because that's the part that's missing, but its slope is 3. So it does have a slant, it just starts right here at the origin. Knowing the difference between those two things is important, but I think you do, because I think you're great and awesome and fantastic. Even you, person who's looking at this thinking I'm not talking to you, but I am. I sure am talking right to you. Unless you muted me or are not watching, then I'm not. All right, don't forget to like and subscribe. Just kidding, don't do that. And I'll see you next time on Math with Mr. Ellis. It's easy if you know how to do it.